Audio Jungle.
Hello, my name is Ana Karen Morales.
My name is Monica,
And my name is Sofia.
and we're here to talk to you about calculus.
This is our second partial project and it's about the home mortgage. This is a problem we chose. And as you can see, here we have the graph that represents the function, the problem we're about to solve, and a turtle. And this.
So the problem states that the term T in years of a 200,000 home mortgage at 7.1% interest can be approximated by T equals 13.375 ln times x over x minus 1250.
Okay, so and it states that this happens where x is bigger than 1,250.
And X is the monthly payments that the owners of the house will make. Here in the graph, you can see that as the restriction says, X has to be bigger. So the graph starts on 1,250. And you can see how it moves by the payments, the monthly payment of the owners,
Like
and the function.
So you can see it goes up because it's bigger. Okay. So this is letter B of our problem, and it says, use the model to approximate the term home mortgage for which the monthly payment is $1,398.3, and it is asking what is the total amount paid. So first we have to notice that T is equal to years. T is time, and X is the total amount paid. That is what we're looking for. And if we want to find X, we have to find T first to solve the problem. So the only thing you have to do is replace this number, this amount, into your X's, and you do it like this. Okay, so this is what you plug in into your calculator with the LN and everything. And your answer is 30. So this means that it is 30 years. Now that you have your T, the only thing you have to do is multiply the given amount by the years, like time. So you do it like this. This is a representation. And your answer? This is your final answer, and this is the total amount paid.
So we have this problem which is exactly the same as the past one. And the only difference is that we have a different amount, but they're asking for the same, the total amount paid. So first we need to remember that T is equal to years and X is equal to the amount. So first we need to get the time to pay the total amount paid. So first we need to copy the function but insert the amount in X. So now we insert this directly into the calculator, which gives us 19.99 years. So the next step we need to do is multiply the time times the amount. We put this directly into insert it directly into the
This is part D of our problem, and it tells you that find the instantaneous rate of change of t with respect to x when x is equals to $1,398.43 and $1,611.19. And the first thing you need to do is derive the original function, which is this one. This is the original function, and you have to derive it by taking the u, and as it's a ln, this is the u, so your u is and as it's a fraction, you need to have f of x and g of x. So your f of x is equal to x, and your g of x is equal. I'm gonna bring it over here. And when you derive these two, you're gonna get that f prime of x is equal to 1 and g prime of x is equal to 1, as this one cancels out and x alone is 1. So you're gonna put it in a function, and it's x times 1, that is this with this, minus, because it's a fraction, this times this, so it's times 1. So, all over g of x squared, so squared. This is your derivative u. So this is u prime. Then you're gonna put it over here. So you're gonna do and you're gonna like multiply already, you're gonna solve it, so it's and the x cancel with the other x, so you cancel this with this, and then you have all over this, and this is, then you multiply this by this and you'll get t it's equal to and this is your derivative function. And now that you have this, you have to insert this in the x and this in the x, so you have to do it twice. And I'm gonna erase so we can do it perfectly. And to be clear, I'm gonna rewrite what our derivative function. This is our derivative function. So now we just have to replace the x's. So first we're gonna do 1. That is gonna be this one. So you're gonna put but in x you're gonna put this. And it's gonna equal so you're gonna put it in the calculator like that exactly, and you're gonna get gonna get and for the second one, you're gonna do the same thing, but with this number. And you're gonna get and these two are gonna be your rates, instantaneous rate of change in change of t with respect of the x's. This one for this one and this one for this one.
So our last question is, what is the benefit of highly monthly payments? Because it reduces the principal loan amount faster, resulting in less interest owed and a shorter mortgage term. In other words, you save